All right. Well, hey, let's go ahead and kick things off. Welcome, everyone, joining us for SolidWorks Live. We're going to take on an interesting topic today, the evolution of manufacturing, which is going to be a fun topic. Most of us who design in SolidWorks, we've one way or the other got to figure out how to get the thing built. And so obviously manufacturing plays a really key, critical role in that. And I am excited to have a colleague of mine, Chris, join us today. Chris, welcome to the show. You're going to walk us through some pretty exciting stuff. But I also, before we get started, want to encourage everyone in attendance to join the conversation in the chat. Take a minute, we'll ask questions as we're going along. I'm going to do my best to follow the chat as we go and pipe those questions to Chris. And so, join us, have a conversation with us in the chat. Should be a lot of fun. But Chris, let's kick things off. And where are we going? Where are you going to take us today on this?
Yeah, let's talk about that. And just really quickly before I get started, I would love to have a conversation with all of our viewers. And, those of you that might be this might be the first time. This is what this is, right? Lives are Steve and I talking with our users and, the community. So please, any topic, bring it in. So today I'm going to be talking about manufacturing and pretty much the evolution of manufacturing and how important what Dassault is doing for manufacturing, right? In the ad, I called it dope. It was funny. I was talking to Sean about it, and he says, I'm just really excited about manufacturing, So I threw a bunch of D words out there like dangerous, dark, dirty, dope, and he torqued the one he grabs onto is dope. But absolutely, I mean, I would say that it's so really exciting and a game changer of how. And what I'm going to do is, this isn't a sales pitch. What I want to do is kind of tell everybody that's viewing and explain how the platform and 3D experience itself handles data and why that's so important in manufacturing.
Okay. Yeah, I think that's interesting because I know both as an AE and a little bit from experience, right? This handoff between design and engineering and manufacturing of those models, it's historically been a little interesting, like the back and forth, that data transfer and making sure the right thing is getting there, that the code can be created off of. So I think this is going to be this will be good.
Yeah, for sure. I'm really excited about it. And okay, so for the record, I hate PowerPoints, right? So, but I think if you don't mind, I want to take 2 minutes just to kind of explain, because if we give everybody the overview, I think you're going to understand a little bit more. And we were talking about handoffs, right? So whenever this is the evolution of any product in the world, right? We don't make cartoons here, we make products, right? We're making great engineering models and things like that. So everything goes right from an idea design. We know this. We've seen this a million times, right? But here's the problem. And this is something that people just kind of deal with, right? So what is getting handed off? When we talk about throwing stuff over a wall, what's getting thrown over the wall, right? So from the idea, it's a piece of paper, right? And then what's getting thrown over the wall from design to engineering, right? It could be a Rhino file. It could be anything, any kind of file. It could be a scan, right? So then in engineering, we're producing solid part files, solid assembly files, maybe IGES files. Maybe you're not, unfortunately, using SolidWorks, right? Maybe you're forced to use something else, right? So you get other files. And then so on and so forth, you can see throughout this whole thing. And that's the problem, because let's say in manufacturing has a problem, right? And they have a Mastercam file. Hey, I want you to see this Mastercam file. It doesn't go backwards. Like, you can't go back and make it a design file. And that's where we really run into problems. And that's where the parametricity and the parametricness, I always get those confused. It's one of those. Being parametric, there you go, is super important, right? And that's what we talk about SolidWorks all the time, because you can go forward and back in SolidWorks. It doesn't make a difference, right?
Dude, let's go with parametricity.
I love it. Parametricity.
I've never heard of that, but I mean, let's just make it a thing.
It's it today. Parametricity. I want everybody to use that at least 2 times today. All right. So what happens when we take those files away, right? What happens when we take those file extensions away? Wouldn't that be great? Wouldn't it be awesome if we had one file extension with no translation whatsoever, all the way from an idea all the way to shipping? Wouldn't that be wild, right?
Yeah.
Well, that's really what we do, right? With 3D Experience Works, not only do we have that one file, but everybody's in that platform. So everybody has access to that same file format throughout the entire process. So listen, I said this isn't a sales pitch, and it's really not. And really what I'm trying to do is kind of explain and making a foundation to understand that the way we've been doing things up to now has been great because those were the tools we had, right? We have better tools now, right? We don't have point solutions anymore. We have cloud solutions, right?
Nice.
We have faster everything, and I'm sorry, I get really excited, but anyway, I just wanted, again, I hate PowerPoints, but I just wanted to point that out so we're all on the same page.
No, I think it's good. And I think, I actually got to experience a little of this with you firsthand the other day, where you and I were working on a project and you're like, no, all I have to give you is this 3D XML and it's going to have everything you need. And I was like, that's amazing.
Yeah, you're absolutely right. Yeah. And it's great. And the thing that I like about it the most is it's pretty much seamless throughout. And what I would run into the shop, and I'm gonna stop making this sound like sales pitch, but when I was in the shop, really the biggest thing is I was using SurfCam back in the day, so I was doing surfaces, and then I'd get SolidWorks files, and then I'd have to translate them and things like that. And we all know, we've all been there, when you're in the shop and you get that's funny, Eric. When you get a file in and you have a problem and you got to send it back, you have a bunch of files, right? This is what PDM is, right? Is managing those files. But what happens when you don't have to manage 20 different types of files, right? It makes your day just so much easier, for sure.
Okay.
Right.
So should we get in? Get into the software a little bit and see
let's do
some of this in action.
Yeah. So I think there we go. Sharing my screen. All right. This is awesome. So what we're seeing here is what we call a manufacturing cell, right? This is called a bowhead swing arm. You guys really, bowhead, remember that name because we've been doing a lot of stuff with their data. You might have seen some videos that Steve actually put together that were phenomenal. So if you see any of those, make sure to see them. But so this is a machining cell that we made with their data. And in this cell, right, we have a couple different things going on. We have a robot, and we also have a CNC machine, right? Those are the cells. So really what I could do is, actually, let's do this first. Really what I could do is open these up in their own software using the same file and things like that. But really what I'm able to do here is program this part and simulate this robot all within the same file, right? There are some stuff on here I could hide. So let me go ahead and just hide a couple of these. Oop, there we go. Center it on there. There we go. Come back. There we are. All right. So we saw the robot. Let me go ahead and play that again. So we saw the robot simulation. It's great. It's awesome. It's going to play. I love robots. Hey, if anybody in the chat, if you guys are using industrial robots, just give me a +1 or something in the chat. It'd be amazing. So as I'm going through this, I want to point out a couple things that are pretty rad about this too. So what we're used to is digital twins, and digital twins are basically just a graphic representation of what you're doing, right? It's just whatever. It doesn't have any data. It's like a cartoon. It's a 3D square cylinder, whatever that you can spin around. A virtual twin, what we're talking about here, actually takes into consideration the kinematics. And because of that, I can do things like simulate in real time, right? So this is sped up, right? But if really with the feeds and speeds that I have, I can actually, this is what it's actually going to look like on the shop floor, right? This is how fast it's going to go. Okay, so enough of robots. That's great. So let's talk about, that's only one part of the manufacturing process.
Can I ask a quick?
Please, yeah, bring it.
So in some ways you look at this and this is like just a cool animation, but I guess what are you saying that this is more than that? Like it's not you're programming the robot, but then you're also able to analyze. I guess maybe you're saying the cycle time related to the part as it relates to that robot and the machining that's happening.
Absolutely. Yeah, absolutely. And one of the when you're in the shop, right, feeds and speeds are important, right? Like how fast this is going to go. And that's one of the, that's one of the things us machinists kind of, oh yeah, it's voodoo magic. You guys don't know, you guys can understand it. But what this is doing, right? One of the reasons it's so elusive is you can't, 99% of the time with the software out there, you can't actually see on your screen how fast that tool is going to move, right? So with a virtual twin, right, what you're seeing is the actual speed of that machine. And that's something that's pretty rare.
Okay.
You know,
And so I guess the other question I have is like, so did you build the machine, or is the machine, is there like a library of them that you're able to pull from?
Yeah, that's a great question. And both of those are right. So we have a library of machines, some generic machines that we are, that we use, that we can supply to you. Your best source is probably the reseller who you buy the software from. They're really good with, if you have a strange machine, like, I don't know, some built in Italy, 18 axis, crazy laser cutter, I don't know, whatever. Yeah, we can model that for you without a doubt. We can model that for you for sure.
Okay.
Yeah.
Looks like we had a good question come in. What role and app are you using? Mike Buckley, hey,
yeah.
so Mike, robot programmer is the role it's being shown, and factory simulation is what's being used to calculate the throughput. So that's awesome.
So I'd like, that's a great question. And Daniel actually asked this question too, like, what role and app are you using? So another thing that I really appreciate the way Dassault's doing this, excuse me, is instead of just an app or okay, so applications now are programs, right? Like Mastercam's a program. No, we're talking about apps now. So when we talk about apps, right, they're basically programs. Okay, so I like it built in Italy too. What Dassault has done is they realized that if you have a role in your company, let's say you're an NC shop programmer, right? This is going to be your role. When you have this role, here are all of the apps you're going to need, right? If you have that role, it's broken down into these apps. You're going to need to collaborate. These are these top ones here. You're going to have to program some stuff. Here's your laser cutter. Here's your shop floor programmer. Here's your wire EDM. It's amazing, right? But that's different than maybe somebody that is a SolidWorks user, right? They're going to have simulation. They're going to have a simulation user. Another manufacturing, like somebody said robot programmer. That's the role that you're seeing right now with the robot, right? They don't need to program a machine, but they need the collaboration. So when we talk about roles and apps, like what role is this, right? Right now, I'm in the role of robot programmer. I'm going to switch in a second to NC programming. And we can do that a couple ways. Go ahead, please.
Yeah, no, it's great. So we ran a quick poll with the audience, and it's just they gave us feedback. 65% have not actually worked with industrial robotics before. So that's kind of interesting.
That is interesting. That's really interesting. And I can tell you that for sure, if you haven't yet, you're gonna. There's 400,000, I believe, was the number of robots entering the market every year. Industrial robots. So, if you don't have them now, they're definitely closing in on you for sure. We've seen some really interesting applications for industrial robots, not just pick and place, which is what you saw, welding, material application. I joked about the D's in the beginning, and we talked about dirty, dark, and dangerous, right? So if you have anything in your facility now that's any one of those things, you're definitely going to have a robot at some point for sure.
Yeah, definitely. The thing I've seen a lot of is definitely like the welding robots. Just the ability to, I guess you'd say, the repeatability and the ability to get into places where it would be tough otherwise to get to.
You're absolutely right. You're absolutely right. I was working with Mike Buckley, actually. We were going over a welding program together, and it's a little bit of both, right? There's parts that are just made for people, because people can bend in weird ways and lean over, and they can take a little bit of liberty with some of the applications, right? It's not exactly at a 30-degree angle. I don't care. I'll just blob it in there, whereas with robots, you have to be, a lot more specific.
Sure.
Yeah, for sure. All right. So here we go. I opened it back up, got out of Robot Programmer, shop floor machining.
So this you're taking us into now, transitioning from robots, it sounds like, into the programming of a part.
You're absolutely right. So within this whole cell, what I did is I activated just the CNC machine. So remember, I'm just going to go ahead and I'm going to hide them, but I'm not going to delete them. I'm just going to go ahead and hide the robot here. Go ahead and hide these things too. So what we're seeing down here is this is actually, not only is there robotics programmed on this, but also factory flow and factory automation. I didn't have time to go over that today. That'll be another one for sure, is factory automation. And we talked about that a little bit, you and I, Steve. And, that's another big part of manufacturing that is becoming very, very important, is is really getting the most out of your factory. All right, so you can see I'm in shop floor machining. I did a couple things, right? I hid the doors so we can see it. So now let's go ahead and we can just check the tool path on here. And again, what we're looking at here, this is another virtual twin. Like, this whole thing is a virtual twin, right? So what we're seeing here is really what we're going to see on the shop floor.
Okay.
Come up here. Let me go ahead and turn on some material removal, because that always looks cooler. There we go.
Maybe while Chris is doing this as well, to the audience, what are some of the challenges that you're facing with manufacturing, whether it's your CNC machining, your floor layouts, your through cycle times? What are some of those things that you guys are looking to really challenge and get some resolution to in your own plants?
Yeah. So I can come in here. That's a great question. And that's what we're here for, you guys. I mean, we're here to help you guys. And this is great, right? This is whatever. It's CAM. You've seen it, right? I'm going to come here and I'm just going to show just really quickly how we can. Let me double click on here. So just for a second, I'm just going to show the programming part of this, just to bring it into full circle. So right here, I can actually come around. I can actually change the tool on this. Right. I said, oh, okay, I can just, whatever. I want to pick another tool. My tool lists are here. I want to use, I don't know, I forget which one. I have a 3/4 inch tool. Simulate that. It'll show it. Now, let's keep in mind for a second, like, how this whole thing started, right? I started with, let me go ahead and get out of this, a complete model. A complete manufacturing model. And this is the part that when I was talking about, this is dope to me. This is just absolutely ridiculous to me, is that we started with robot, and I just went ahead and I just hit it. And I said, let's go ahead and let's program this machine. There was no, okay, I want to take that robot. I'm going to close down my robot programmer. I'm going to open up my CNC machining now. Okay, hold on. I got to wait for that to load, right? There was no, hold on. Okay, I got this file. Let me drag it into this window and open it up. Everything not only happened in the same window, right? Each app worked in the same program, right? I never left this. It's amazing. This is the part that's incredible to me. You don't ever have to bop over from Mastercam to SolidWorks or SurfCam to something else. It is just absolutely amazing.
So Eric had a good question. Can you clarify if this is the same NC shop floor programmer role that is available in the SolidWorks Maker subscription, or is there a more expansive role with more apps?
Both of those are true.
Okay.
What you're seeing right now, there's 3+2. I'm sorry. So with the regular shop floor programmer role, you get 3-axis plus 2 positional, right? So we call it 3+2. So you can move it, machine it, move it, machine it. The more expansive roles are, I'm sorry, let me back up for a second. You get 3+2 plus, you get single point cutting. So lasers, water jets, you name it. And nesting. So that's all that you get with the Maker stuff. Now, when you talk about advanced roles, right? When we do the way that we did the pricing on this is we didn't want to nickel and dime you. Like, we're not going to charge you, oh, you need machine simulation, that's more. No, we broke it down into, okay, now you want to do mill turn, that would be the advanced option, right? It's really by the size of your machine after that and how much you need to do. The most advanced option would be multi-axis mill turn. But yeah, all of the features you see that I'm doing right here come with the base rolls.
We have Mahita saying, I want to name that single file as a gigafile.
I love it because it's way better than a mega file.
Yeah, it's fair. It is interesting, when we talk about the evolution, the kind of the topic of the day is that it feels like you can get into this at any entry point you want. Like if you're trying to machine that, and that's all I want to be able to do, then great, build your CNC code and whatnot. But if I'm part of that, 65% of the audience that's never done robotic programming, at the point that I'm ready to be able to do that or want to be able to do that, I can, right? It's that same environment that you just talked about.
Absolutely. Yeah. And that was one of the things I really loved when I was in the SolidWorks channel was, I'm going to age myself again. I think I used SolidWorks to design the wheel. And I think that speaks for the age of both me and SolidWorks. But when I was in there, it was so cool because that was the first time I'd ever really seen you could be in one window and they had Cosmos back then, right? But if you don't want to do simulation now, you can do it later. And it's right inside the same window and we just added on, right? This is the evolution of that, right? This is the evolution of more than just, oh, if you want it, we can just put a little hook in it and add it on. All of that, again, manufacturing is data now. It is. And the way that we handle it. And that's the thing that I really wanted to point out. Imagine the amount of data that I'm pushing around here, right? Motion data, kinematic data, weight, velocity, all of these things are taken into account in this. And, I love SolidWorks and all, but I challenge any standalone program to be able to use data the way that we're able to in this platform. And even leveraging the SolidWorks data in here is just absolutely incredible. Absolutely incredible.
So I guess that we've got probably a lot of SolidWorks users obviously on the call. What happens when they make a design change? And I might be getting ahead of you, but what happens when that model geometry changes with what you've got here?
No, that's a really great question. So there's a lot to that, right? There's a lot to change orders, depending on the way your organization is built, right? I've worked in small shops, mom and pop shops, where it was me and another guy running 3 machines. Change orders were the boss coming out and saying, hey, stop, change it, and giving me the new file or something, right? There's still shops like that out there, but I think more than likely there's a chain of command there, right? It's going to go through the engineering department and all that stuff. There's all this documentation. And the nice thing about that, is at that point, we can just come over here and say, okay, what's the part that we need to change, right? Because we can come up here and just say, we're just going to go ahead and replace that part. Oh, I can't find it right now, but it's in here. So we can actually just come in, take this object and replace it with the new part. Because, remember in that first, in that PowerPoint, I hate to use it, the graphical representation of the thing. Now that PowerPoint that I did at the very end, right? We're all in a square together. We're all there together. So if there's a change order, it's the same file format, right? It's in the same folder. It's in the same group. It's in the same project. It's great. Yeah.
Okay. All right. Good. So I can swap that new geometry in and everything.
Yeah. It's just,
downstream. Okay.
For sure. Yeah. So Steve, let me ask you a question, or everybody on the line. Let me ask you guys a question, right? What is the biggest problem that and this isn't a loaded question because I want to know, I really honestly want to know these days, what is your major hurdle when dealing with manufacturing, right? I can tell you what I think it is, right? But I'm kind of biased, right? So what is your biggest hurdle? What do you think? Honestly, Stephen, again, this isn't a trap. I really want to know, like, what do you think the biggest hurdle is?
man, I think I guess I would wager to say I guess I'll take the perspective between maybe engineering and manufacturing is like communicating the accurate data back and forth when changes
Mm-hmm.
do happen.
Mm-hmm.
I get the sense that that still is there's still some heartburn associated with that handoff between
Mm-hmm.
whatever, SolidWorks and then
Mm-hmm.
whatever CAM solution you might be utilizing in reconciling what's been designed with what actually can be machined and maybe
Mm-hmm.
what needs to be added in order for it to be successfully machined,
Mm-hmm.
whether it's
Mm-hmm.
hold points or things like that. So I don't know. That would be, I guess, my guess. I'm with you. I'm kind of
No, 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 no. There's no, yeah, no, no. There's no wrong answer. I think you're right. I mean, I think all of that. We see some stuff in the chat. I mean, a lot of people are talking about communication of data, right? And that's kind of what I thought too. Being in the shop and being a shop guy, right? I mean, we're kind of at the, and not in a discriminating way, but we're kind of at the bottom of the chain, right? Everything kind of comes down to us, right? So when you think about the chain of command, there's the amount of data grows, right? From the design, from a napkin sketch, all the way through engineering. By the time it gets to us, there's just so much. And I think that really is the problem. And, back in the day, again, I mean, when I was doing my apprenticeship, we were running off of drawings, and we would sit there with a drawing for an injection mold, and we would just go over the drawing for a few days and just talk about how we're going to do it and who's going to do what and how all of that stuff's going to work out. And that was the way that we communicated. And it was slow, and I think that's really with what our customers need today. What I'm seeing with engineers, it's speed, man.
yeah.
It's absolute speed. And the SolidWorks users are so incredibly fast. It's so great.
So this is a great point that I think Daniel, his view on is manufacturing is not just NC code to control or its process. What
Yes.
tools, setups, tolerances, what to inspect, what surface treatment. Yeah.
Yeah. So you hit a bunch of things there, Daniel. So this is another great thing that I really like about Delmia and the way Delmia handles data. They use those, right? So it's not just NC code. Absolutely. Thank you for saying that, right? It is a process. And that was kind of the idea of that first slide, right? It's not just, okay, here's NC code that. What we really want to talk about, what we really want to do is solve the entire manufacturing problem, right? Here, let me share my screen just really quickly again. And you can see that machine. Now I drilled down to the part, right? I started with this big manufacturing cell, and then I hid the robot, just showed the machine, showed that. But if we dig down even deeper, right, we can see that on this machine, we actually have these accessories that have their own mechanics, right? Their own representation, right? Their own moving parts. And we can create work instructions from these vices and ship those with the part or with the code or whatever to the shop, right? Tighten vice ABC before you do anything. It's huge, right? The nice thing. Go ahead, please.
Yeah. So, okay. So I'm going to stop you just for a minute because that's kind of interesting to me.
Bring it.
So is that information something that's just been built into the intelligence of that part? Like I have this vice and I'm going to build that out as part of that vice's, I guess, attached data that I can then utilize.
Absolutely. Yep. So you build it out. That's another great thing, again, about having a virtual twin, not a digital twin. If this was just a digital twin, I could just take this, highlight it, move it in, no repercussions. It would happen, right? No big deal. It's just but if I did that here, right, it really affects the entire, here we go, it's this one, the entire tree of all of these parts because there's so much to that, right? That's really important, right? And once you build this, you can reuse it throughout your facility. Now, one thing that I just want to point out really quickly is, we've shown this to some people, and one of the things they say is, I don't want to have to build my own machine. I don't want to have to build these vices. I have a vice. I just want to throw it on the vice and do it. And that's great. And you know what? You can do it. You don't have to do all this stuff. You can make you just make a digital representation and go for it. But at some point you're going to have to go to the shop and you're going to have to put a vise on your table, right? And you're going to have to zero that tool out, right? You're going to have to put the material on the vise, and you're going to have to, and now all of a sudden, maybe it's exactly what you had on your cam, maybe it's not, right? Here, you know for sure it is, right? Again, the virtual twin, it has instructions, setup instructions. You've modeled this exactly like your machine. So there's no surprises. There really isn't. And it's great. And so going back to John, just a couple of things too. We talk about tolerances, what to inspect, surface treatments, what's important, what's not important. So that's manufacturing instructions, things like that. That's a whole different thing. And that's a SolidWorks part, and they're working on it. They're doing a pretty good job at that, it's great, Daniel. Thank you. And that's really the point of this, is encompassing everything that has to do with manufacturing, not just NC code.
That's great. So I guess I'm intrigued now a little bit. Are there other little like hidden gems, like the work instructions and whatnot that just come along for the ride once you have this stuff set up in your library?
Yeah, there's all kinds of things you can do. So this is kind of like the middle step of the entire process. I went ahead and hid these in the beginning, these behaviors. And really what these are for is these are to show the movement on the shop floor, right? And I have a video, but I'm not going to bore you guys with another weird little video. But by going one step further with factory automation and our shop floor, our factory simulation, is you can actually generate reports about the entire process. How long each one of these things are taking. How long is the robot moving? How long is it taking to move a part? How long are these little carts taking to bring material to the arm? How long is the machine taking, right? These are all reports that, back in the day we would print out, right? But, now we have these things called dashboards. And on these dashboards, we have these little widgets, and I don't have any set up right now, but we have these widgets where you can just say, hey, you know what, show me the current state of these carts right now. How long is this taking? So it's a constant real-time update of what's happening on the shop floor. And that there's a little bit of magic there with something called DelmiaWorks. Not a lot of people have heard of that yet. You guys on the line, trust me, you're going to hear a lot about DelmiaWorks in the coming year. So keep your ear out. But the things that you're able to measure, analyze, and report within the platform is incredible.
So what happens, Chris, and I guess I don't want to deviate too much from your presentation here, but
bring it back.
One question I did have is so I think we've talked a fair bit about kind of this evolution of the data flowing towards manufacturing, engineering to manufacturing. But what happens in situations if information needs to go back the other way? Like, let's say I need to like redline something, or I need to point out something that engineering design needs to adjust before I can machine this or create this part.
Yeah. So inside of this, and I'm trying to find the icon because there's a couple of them. We actually have a markup feature that you can actually create markups in this window using the 3D model setup. No, it's somewhere. I forget. Oh, standard menu. No. So I apologize for this, but I didn't organize my my markup tabs enough. I apologize. But yeah, you're able to actually create 3D markups and actually share them across your facility. And within the platform, you're actually also able to send alerts to the designer, the engineer. You can basically label whoever you want to alert when there's a markup. And the nice thing about these markups is they actually attach themselves to the file. So let's say I open this up. Remember, again, to remind everybody, this is all one quote unquote file that I opened up. It's a 3D XML file. And really a 3D XML file is a file that contains a bunch of objects, right? So within those objects can be, your reports, your markups, and things like that. And we also have co-review with peers. So you can actually do a review of the part live with through either chat or through the platform. You know, it's
Okay.
funny. Mike lives in Nebraska, and he was working on a part for his tractor, and I was kind of helping him while he's in the barn doing it. And it was actually pretty incredible. I think we actually used the chat feature and the picture feature and the markup feature back and forth for me to kind of help him. Okay, this is where that goes, and instructions like that. It's a pretty incredible feature. And again, it's all about communication and that open flow of communication.
Yeah, that's a great point, right? Because so many of the manufacturing is dispersed in a lot of ways, and so having that way of I can see where that would be really valuable, being able to all
especially now,
the same thing.
Mm-hmm.
This is so. I guess another thing, question that comes to mind. And by the way, for our audience, if you have questions, by all means, please put them in the chat. I'd love to pass those along to Chris. But Chris, when it comes to like the tooling and the fixtures, the work holding, and I guess even the code, is that able to be versioned or revision managed and kind of, I guess, traced, if you will? Like, is there a way to correlate all of that in case, something does change and we've got to be able to get back to, what it is we used when we built that part?
Yeah, that's a really great question. So there's us in the shop, we've figured out ways around these things, right? Like, okay, I'm going to try this. I'm going to put this file over here and monkey around with it, but this one over here. And, it just becomes so confusing, right?
Yeah.
With the file management here, what we can do is we can actually go back to earlier versions that we've created of the toolpath of the part. All the toolpath, again, is all contained and referenced to this model. So it's difficult for me to convey what I'm trying to say because everything's so different than what I was used to and what everybody on here is used to. We're talking about files, and it's really not files. We're really talking about objects, right? This machine, right? This machine, I don't have a file of a Haas, right? This is my object, is my Haas. And in that object are all of these things. So that being said, an object can be anything, right? It can be a machine data. It could be an NC code in a text file. It could be a PDF. It could be whatever you want it to be. So within these files, it can contain revised versions. There we go. Of earlier context and past versions too. Yeah, it was a tongue twister. Yeah.
Okay. Cool.
Yeah.
Very good.
So, okay, let me ask you guys on the chat. We're all honest, right? This is the tree of trust, right? The tree of engineering trust here, right? Do you guys engineer? I'm not just going to assume engineer. We'll go both ways. Engineers, do you feel like you have an open line of communication with the shop? Like, do you feel comfortable going down the shop and being like, guys, there's a change, and vice versa, right? Manufacturing guys, like, do you feel comfortable going upstairs and being like, hey, I can't machine this, And I would think that machinists are kind of more crabby. I'm one. I can say that just for the record. And I'm grouchy. And I've been up to engineering and said, seriously, like, why is this whole, 0.490, dude? Come on, man. Like, you don't want that, But just curious, let me know what you guys think. Because we don't like talking to people anymore in general. Right? We're machinists and engineers. We didn't like talking to people before. So now after COVID and everything, we don't like talking to people even. I mean, we like talking to people less, right? So that's one of the other things I really love about this is because when I deal with people like Steve, who I like to talk to, right, we can get on the phone and we can discuss it, right? When I have a file from somebody else, I can really mark it up and I can get that communication to them and get that information to them in a succinct way, right? Where they'll understand it without me having to talk to them, right? That's the ... without me having to talk to that part. So that's really why I'm curious about this, like how you guys feel about that, right? It's important for us, Steve, and I think you'd agree, right? Let's be realistic. We both work for Dassault, and we love our jobs. We really do. And it's amazing. But we have a tendency, I feel at least that I need to reach out, right? I need to reach out to the community and remind me again, like how you guys are feeling. How is that? Because I don't want to tell you how you feel. I want to know. So thank you. I was just curious. I'm really, really excited to see that poll.
Yeah, we've got a poll going. By all means, go ahead and answer. We'd love to have that feedback. And I think, Chris, I think it's a good point. I think sometimes we do have to step out of our comfort zone. I know when I was in industry, I believe it or not, was actually fairly shy, and sometimes out of necessity, and sometimes just out of pure need, would definitely go talk to the machinists and the welders and whatnot. And what's funny is that as I did, I always came away better for it, because I would gain insight, I would gain knowledge in, better ways of doing things. And there's a little bit of a strange wall sometimes between those two that really probably doesn't need to be there.
Yeah. No, you're absolutely right. And, when I was coming up through the trades, it was like dealing with the crabbiest uncle you ever had. Like you had to ask him for like a ride to school or something. And you're like, oh my God, I got to talk to this guy again. But I think it's changed a lot. I think a lot of people have gotten humble with what they know, because technology has gotten so advanced in manufacturing. Sure, you have the old European machinists, right? They can do everything by hand. They can cut these angles freehand on a mill, like it's crazy. But we need those people in the trades, right? But we don't need to rely on them as much. And I think they realize that. So I think a lot more people these days are a lot more willing to not be that crabby uncle, right? And be more willing to say, hey, come here, let me show you how this is, because us old guys, right, we need to know about what's coming up and what's important to the engineers. I think that's really, really important.
So, Chris, we're heading into the last part of our time together. Is there anything else you want to share with us or convey about kind of how this is evolving?
Really, the biggest thing I want to point out is you used evolving, and it's such an amazing word for this. It really, manufacturing, everybody on this, I mean this from the bottom of my heart. I'm seeing it. I've been around. Manufacturing is evolving, right? It's not getting parts on and off the machine is the priority anymore, right? Sure, it's there, right? But the priority is not getting the part on and off the machine. It's getting the part in and out of the shop, right? And that's what we realize. Really, I want everybody to realize that everybody on this line, I'm just going to go out on a limb and say, everybody on this line is an amazing SolidWorks user, right? You guys could crush it on SolidWorks, right? That bottleneck in engineering is over, right? You guys, everybody on this line, you guys have helped eliminate that barrier of design barrier, right? Because we're so quick. What's the next barrier for getting that part out of your building, right? It's manufacturing. Yeah. So, really kind of pay attention about how those lines are bleeding over, especially pay attention, honestly, even in Outlook the next year or two. And I'm not just saying with Dassault, this isn't anything with us. I'm just saying in general, the next year or two with AI and robotics, those two things with software and hardware are really going to change what we see as manufacturing. And I just wanted to say thank you to you, and thank you to everybody that was on here. If you can't tell, I love talking about making stuff and manufacturing and software. Reach out to me, everybody on here. I'll talk to you forever about this stuff. So, and Steve, I can't thank you enough for having me on here. Thank you.
Yeah, no, we've enjoyed having you, and to your point, it seems like things are trending in a positive way. 65% or 62% of the people responded feel like, yeah, we've got an open line of communication with
Awesome.
With the shop. So I think that's great. That's really encouraging. So
absolutely.
Very good. Well, Chris, thanks again for spending some time with us today, answering all my my dumb questions about manufacturing and helping to educate me on some of this the trends in this as well. So I appreciate it.
Always a pleasure.
For everyone on, I want to make you aware of just a few upcoming things that we have in the works when it comes to our live series. One of which is on August 31st, we have the Best of Live Design 2023. So this will be an amazing opportunity for you to get a catch up, kind of I guess we're a little bit past the mid-year, but just an amazing chance to get all caught up on any highlights that you may have missed. You'll have an opportunity to do so on August 31st. So be sure to make sure you're subscribed and have the notification bell turned on when it comes to that. Another event that we're excited about is on September 5th. We'll have a manufacturing live. This is going to be a great one. We're going to have Tom Buxton, who's a technical manager from one of our partners, talk about his journey into a career of manufacturing. And so that's going to be a great episode that you're going to want to tune in for. And then finally, this is the big one, the one that I know a lot of us wait all year for. You've got experience, 3D Experience World, and you've got What's New, right? Those are the two things that we all get very, very excited about. And so we're going to have our What's New 2024 SolidWorks live episode. We're going to have a number of experts on walking you through the new functionality, the new features. You're not going to want to miss this. And this is going to be a special Wednesday episode of SolidWorks Live. So a little bit different. We typically do these on Thursdays, but this one you're going to want to make sure you get on your calendar for Wednesday, September 27th at 11 a.m. Eastern. So again, be sure to subscribe, turn the notification bell on. You know how this works, the drill, but we really do want you to be informed of what's coming up, because there's a lot of great speakers and a lot of great content in the works for the rest of the year. So with that, again, I want to just extend a thank you for joining us today on the evolution of manufacturing. I hope you found it helpful, insightful, maybe walked away with a few insights related to what Dassault is doing from a manufacturing standpoint, and maybe some things that you can just be challenged on a little bit to think about in the way that your manufacturing operations are currently working. So with that, I want to wish you a great weekend. Enjoy the rest of your Friday, and we'll see you next time.